Security by design is always stronger than security by reaction. Welcome to this session on Module 5, Physical Security, Chapter 5, Basic Design Concepts in Physical Security. In this chapter, we move beyond measuring performance and focus on how to design effective security systems from the ground up. A well-designed security system is not accidental. It is the result of structured planning, risk understanding, and integration of multiple protective elements. Today, we will explore the foundational principles that guide physical security design and how they translate into real-world protection strategies. This chapter introduces the core principles that underpin effective physical security design. Physical security is not just about installing guards, cameras, or barriers. It is about integrating people, processes, and technology into a cohesive system. Every design decision must align with the organization's risk profile and operational needs. The key focus here is on management principles, protection strategies, and program management. These concepts ensure that security measures are not isolated solutions, but part of a comprehensive and layered protection system. Ultimately, good design ensures that security is proactive, structured, and capable of adapting to evolving threats. All effective security design begins with one critical step: risk assessment. As emphasized in the ASIS Standard 2021, before selecting or applying any security measures, organizations must first understand the risks they face. Without this step, security investments may be misdirected or ineffective. In practice, this means identifying threats, assessing vulnerabilities, and evaluating potential impacts. Only then can appropriate controls be selected. Security risk management influences every aspect of design, from facility layout and structural protections to operational procedures and program management. In short, risk assessment is the foundation upon which all security design is built. There are two key principles that form the backbone of physical security design: the 4 Ds and defense in depth. The 4 Ds, deter, detect, delay, and deny, represent the objectives of any security system. Deter discourages potential attackers. Detect identifies threats early. Delay slows down adversaries. Deny ultimately prevents access or success. Complementing this is layered security, also known as defense in depth. This approach uses multiple layers, such as perimeter barriers, access controls, surveillance, and response forces, to create a comprehensive protection system. The idea is simple. If one layer fails, others continue to provide protection. Together, these principles ensure resilience and effectiveness without unnecessary duplication. Effective security design requires careful consideration of how protection is applied. Point versus area security refers to whether protection is focused on specific critical points, such as entry gates, or distributed across a broader area. Point security is efficient but may create bottlenecks, while area security provides coverage but may require more resources. Conflict avoidance is essential. Security measures must not interfere with operational efficiency or safety. For example, overly restrictive access controls may hinder productivity or emergency response. Finally, balance is key. Security must strike the right equilibrium between protection, cost, and operational convenience. Oversecuring can be as problematic as undersecuring. A well-designed system harmonizes these elements to achieve optimal performance. Security design must also account for unique environments and potential failures. Special facilities, such as data centers, hospitals, laboratories, or manufacturing plants, have distinct risks and operational requirements. These demand customized security solutions tailored to their specific threats and functions. Equally important is planning for component failure. No system is infallible. Cameras may fail, power may be lost, or communication systems may break down. Therefore, contingency planning is essential. Backup systems, redundancy, and alternative procedures must be built into the design to ensure continuity of protection. A robust security design is not just effective under normal conditions, it remains resilient even when components fail. Now let's focus on how security design is translated into measurable and actionable criteria. Performance criteria define what the security system must achieve. These are outcome-based and measurable. For example, detecting an intrusion within a specified time or ensuring a defined response capability. Feature criteria, on the other hand, focus on the physical and technical attributes of the system, such as the presence of cameras, alarms, barriers, or access control mechanisms. While features are important, they must always support performance outcomes. Finally, procedures bring the system to life. These include training, incident response protocols, communication processes, and investigation mechanisms. Even the best designed system will fail without effective procedures. Key performance measures often include detection probability, nuisance alarm frequency, delay effectiveness, and response force efficiency. Together, these elements ensure that security design is both practical and performance-driven. The physical layout of a facility plays a critical role in security effectiveness. A well-designed campus layout considers visibility, access control, and layered protection. For instance, placing visitor parking away from critical buildings increases standoff distance and reduces risk. Similarly, barriers and fencing must be designed to guide movement and restrict unauthorized access while still supporting operational flow. Landscaping also plays a subtle but important role. Overgrown vegetation can obstruct visibility and create hiding spots, while well-maintained areas enhance surveillance. Lighting, pathways, and entry points must all be aligned with security objectives. The goal is to create an environment where threats are deterred, detected early, and controlled effectively. In a sense, good layout design is the first physical layer of defense. Let's now look at practical examples of effective security design. Concealing assets with site features is one approach. By using landscaping, terrain, or structural design, critical assets can be hidden from direct view, reducing the likelihood of targeting and improving surveillance effectiveness. Terrain-based standoff leverages natural or artificial features to increase the distance between threats and assets. Even a small increase in standoff distance can significantly reduce risk from blasts or forced entry attempts. Another example is separating shipping and receiving areas. These zones often involve high activity and external access, making them vulnerable. Isolating them from core operations reduces risk and improves control. These examples highlight how thoughtful design decisions can significantly enhance security without excessive cost. As we conclude this chapter, let's bring together the key insights. Effective physical security design always begins with risk assessment. Without understanding the threat landscape, any design effort is incomplete. Next, security must be layered and integrated, combining physical measures, technology, and procedures into a unified system. No single control is sufficient on its own. Collaboration is also essential. Security design must align with operational needs and involve multiple stakeholders to ensure practicality and acceptance. Finally, always plan for failure and change. Systems must be resilient, adaptable, and capable of evolving with emerging threats. The best security design is not the one that looks strongest, but the one that works seamlessly. Thank you for your time and attention. Keep applying these principles to design smarter, stronger, and more resilient security systems.